All right. We continue with our work. We are now on example 18, okay? We're just continuing from where we left in the other video. What is example 18 saying now? Let's go through it, okay? What are we making the subject, by the way? We are making x the subject now, okay? So we have d is equal to h over x minus f. So we are supposed to make x the subject. What do we see when we look at it right now? Well, I see that my x is in a fraction, so I'm going to have to destroy that fraction. But remember, you only destroy the fraction when it is left alone. Okay? The fraction should be alone, then you can be able to destroy it. Don't try to destroy it right now when this f is still there, that negative f. So the first thing we do is we get rid of that negative f so that we leave h over x, that fraction, alone. When it's alone, now we can make x the subject. So we start by taking this negative f to the other side. It's going to be d plus f, okay? It will do the opposite of what it was doing on the right. Obviously, you now know. It was subtracting, comes to the left, it will now add. And it is equal to h over x. Now I have my fraction, and I must destroy it. I must destroy the fraction, okay, so that I can make x the subject, okay, because my subject is x and it's in a fraction. Now, how do you destroy a fraction? You take the denominator, number at the bottom, to the other side. So x goes to the other side. He's going to now multiply. X is multiplying d plus f, and he is equal to h, right? Now I'm going to make x the subject because he's no longer in a fraction. How do I make x the subject? Should I expand for what? Why would you expand? Because now d plus f, that whole thing, you see, can you see that x is multiplying the whole thing, the whole d plus f? Because d plus f were already there on the left. So when x comes to the left to multiply, he's going to multiply everything that was already there. So that's why he's multiplying the whole d plus f. Make sure you are alert when you do it. So now I'm just going to take this d plus f to the other side. Okay, now I can make x the subject. And I see that d plus f, these two are multiplying x. So I'm just going to take them to the other side. So x is now equal to h over d plus f. D plus f, that whole thing is going to be dividing now on the right because it was multiplying x on the left. I hope you're taking note of the thing. We're now on example 19. It's saying n is equal to t squared over x plus m. Now you're getting used to it. Now you must be getting used to it. So what do I do? First, I have to take m to the other side so that I remain with the fraction alone. I want to break that fraction that x is in because x is in a fraction. Whether he's at the top or at the bottom, we don't care. The fact that he's in a fraction, we have to break that fraction. Okay? But for us to break it, the fraction should be left alone. So we have to take m to the other side. M is adding there, goes to the other side, he will subtract. And it will be equal to t squared over x. Now what do? We break the fraction. How? By taking x to the other side. So now x will go to the other side. He's now going to be multiplying what? N minus m, because n minus m are already there. And it is equal to t squared. You see, things are changing a bit now because x was the denominator. In the other examples we did in previous videos, like video 2 probably, or video 3, x was a numerator, but now he's a denominator, so things change a bit. Okay, so now x is outside your bracket. But don't let it confuse you because you are making x the subject. So you're taking everything else that is not x. And what is that? That's n and negative m. These two are multiplying x. So we're going to just take them to the other side and they will divide. So x will be equal to t squared all over n minus m. You are done. Okay, now we are pulling it up a notch. Let's see how. Let's see how we're pulling it up a notch. Let's go to number 20. We have m minus d over x being equal to e. Now, if you look at the previous examples we did, yes, we had our subject in a fraction. Yes, but the fraction was positive. If you look at this one, this fraction here is positive because there is no sign in front of him here. We said if there is no sign in front, then it's a positive number. If there is a plus in front, then it's a positive number again. But now we have a negative in front of him. So that means this fraction is a negative fraction. And my subject is negative, which must never be the case. Okay, if it's negative, then you can't go ahead and make the subject. You can, but the method we use, you can't. So you have to make it positive. Okay, for the method we use, we say that we must first make it positive before we start trying out to make subject of the formula. All right, for transposition, first you always make the term with x, or the x if it's alone. You have to make it positive first. So here I see, okay, I have my fraction, and this is one line. So this of taking it to the other side to make it positive, you do it when you have one line of terms. So I'm just going to take this fraction to the other side. M will now be equal to E plus, because d over x is now coming here to add. Now, once it's like this, we have gone back where we've just been solving. We are back to the other examples, example 19, 18, whatever. Now, I see that I want to make x the subject. Now I can make it. Why? It's positive. And now I see that my x is in a fraction. Okay, so I'm going to have to break that fraction. And for me to break a fraction, it must be alone. So that means I have to now take e to the other side. So m minus e is equal to d over x. Now, when it's like this, I can break my fraction. How do you break the fraction, sir? By taking the denominator, the number at the bottom. The one at the top of the fraction is the numerator. Denominator is x, the one at the bottom. We take it to the other side. So x will now multiply m minus e, and it will be equal to d. Now, what do? I can now make x the subject. He's no longer in a fraction. Then what do? How do you make it the subject? You take everything that's not x to the other side. X is on the left. What else is there? M minus e. What are they doing? They are multiplying 2x. Okay? So they are multiplying x. I don't know how to say it. Okay? You know the word better. Is it multiplying 2 or whatever? It doesn't matter. Now we're just going to take this m minus e to the other side. So I'm going to have x being equal to d o over m minus e. It's as sweet as it gets. It's as sweet as it gets. Let's go to number 21. Now your mind is thinking straight. I have to take my fraction to the other side. I see x is in a fraction. You think fast. You can see it now. Your x is in a fraction, but the fraction is negative. So we have a mighty problem here. I'm going to have to make my fraction positive. First, before I start thinking about what I do next and everything, I first have to make my fraction positive. So it's going to be g is equal to p was already there. Now my fraction is coming to do what? To add plus q over x. Wow, good stuff. Now it's positive. But now I see that my subject x is in a fraction. I'm going to have to break that fraction. And for me to break it, the fraction must first be left alone. Okay, so what do? I take everything which is not that fraction to the other side. So p has to go to the other side. So it's going to be g minus p is equal to q over x. Really? Yes. Then what now? I take x to the other side. X is going to multiply g minus p, and it'll be equal to q. Okay? Great job. Now what do I do now? I've taken x to the other side. It has multiplied. Now what next? Well, the next thing is now you make x the subject, because it's no longer in a fraction. You make it the subject. How? By taking everything that is not x to the other side. So x will be equal to q over g minus p. I hope there's nothing I haven't said here that somebody's like, okay, what about this? What about, okay, if you have a question, you could just write in the comment section. I'll see it. So now we have 22, number 22. Let's keep going. We want to get all the way up to the end. So now we have another one. It's saying e is equal to t squared minus b over x. Wake up. Now you're alert. Now you can see what's going on. You have a fraction. You have your x in a fraction because you're making x the subject. You're making x the subject. Okay, it's in a fraction and it's negative. I take it to the other side to make it positive. First, equal to e plus b over x. It is equal to t squared. All right, now I see my x is now a fraction. It's positive. Now I must break that fraction. But for me to break the fraction, I must first make sure the fraction is alone. So I take e to the other side. So it's going to be b over x is equal to t squared. What was e doing on the left? It was adding. When it goes to the right, it will subtract. Then now I continue. I have b over x being equal to t squared minus e. Then now, what do? I break that fraction. How? By taking the denominator to the other side. When he goes to the other side, what will he do? He will multiply, because he's dividing. The x is dividing, goes to the other side, it will multiply. So b is equal to t squared minus e. This whole thing is now being multiplied by x. Okay, it doesn't matter if you put it in front or at the back, doesn't matter. The whole thing, we just have to put the brackets to show that. Then now we make x the subject by taking t squared minus e to the other side, so it will be b over, because t squared minus e was multiplying, so now we have t squared minus e dividing, and it will be equal to x. Fantastic, fantastic. Number 23, r is equal to n minus m over x. R is equal to n minus m over x. So what do? I first make my fraction positive. R plus m over x. Don't forget the stages. Is equal to n now. Don't you forget the stages. Make it positive first. Now when you've made it positive, that's for this type of question. Now that you've made it positive, you want to break the fraction because your subject is in a fraction. You should know the reasons. All right. So, but for me to break the fraction, it must first have been left alone. So I have to take this r to the other side. I remain with the fraction alone is equal to n minus r. Because r was adding, goes to the other side, it will do the opposite, and that is to subtract. Now what do I have? Now I break the fraction. So m will now be equal to, I take x to the other side because he's the denominator, x multiplying n minus r. Okay? Then now I can make x the subject by taking everything which is not x to the other side. That's n minus r. It goes to the other side. So m over n minus r is equal to x. You are done. Number 24. Wow, we see a new type of question here. We have the square root of x being equal to 3. Okay? What do? I know that the opposite of root is the power. Okay? The opposite of taking a root is raising to a power. So I have the square root, which means root 2. If I take root 2 to the other side, it will become power of 2. So x will be equal to 3 squared. And that means x will be equal to 9. That's done. I just took the square root to the other side. It became a power of 2. And then 3 squared will be equal to 9. Okay? If you are at a school where your teacher doesn't necessarily use this method, you don't have to argue with them, all right? You don't have to argue with them. If your teacher wants you to use the method of doing the same thing both sides, like raising to the power of 2 both sides, then, you might as well do it. But this is equally correct. This is very correct, okay? This is very correct. If you go through even textbooks, you see the same method. All right. So now we have the square root of x minus 4 is equal to 6. What do? I take the root to the other side. I will have x minus 4 being equal to 6 squared. Okay, so now the power of 2, because root of 2 came to the other side, it will do the opposite. It's now the power of 2. So now I have x minus 4 being equal to 36. And that negative 4, I remember I'm making x the subject, so it's easy. This negative 4 goes to the other side. I have x being equal to 36 plus 4, and my x is equal to 40. Number 26, square root of x plus d is equal to a. What do? First thing first. First thing first. The square root is affecting everything. I take it to the other side because I'm trying to make x the subject. And x is under a square root sign. I have to get rid of that square root sign. It goes to the other side, it will become a squared. So I now have x plus d being equal to a squared. Right? Good. Now, you must know that, okay, we'll see when we do more examples. Let's now take d to the other side. We now have x being equal to a squared minus d, because d was adding on the left. When it goes to the right, it will subtract. Number 27, again, I see my subject x is in a square root sign. Is the square root sign the only thing there on the left? Yes, there's no other number. If there was a number here outside, we would first have to take it to the other side so that square root remains alone. Because square root is like a fraction. It must be alone before you break it. So now I'm going to break the square root sign. Let's just say that. I'm going to get rid of it by taking it to the other side to be the power of 2. So now I have mx plus n being equal to, what is there on the right? It's only d. So d is the only thing I'll raise to the power of 2. But if there was something else, we would raise the whole thing to the power of 2, them both. Now what do we have? Now we are making x the subject. And we have seen a situation like this before. Don't you forget. Now we have mx plus n, and we want to make x the subject. What do? We got to take m to the other side and n to the other side. So who do we take to the other side first? N. Why? He is further from x than m. M is right next to x. So we start with n. Remember that. N goes to the other side. I will have mx being equal to d squared minus n now. Because he was adding on the left, comes to the right, he will now subtract. I hope you're awake. Then now I take m to the other side. M is multiplying, goes to the other side. It will divide everything. D squared minus n, that whole thing is going to be divided by m. Everything that was already there. Okay, so now we can continue. Let's see, how many more examples do we have? Oh, we are ending at number 33, so we have about 4, I guess. Let's keep going. T is equal to the square root of x plus b. Of course, by now we know take square root to the other side, it becomes squared. T squared is equal to x plus b. Okay, is it just an x? I don't know what number this is. I can't really see. Anyway, b goes to the other side. T squared minus b is equal to x. H is equal to the root of whatever. We take the square root to the other side first. It becomes h squared is equal to p minus x. What am I making the subject? X. Okay. I look at him now and I see, he is negative. X is negative. Can I make subject to something that's negative? No. What is the thing I have to do? Take it to the other side to make it positive. So it goes to the other side to be positive. I now have h squared plus x is equal to p. Now that my x is positive, I can now go ahead and make the subject of the formula. How? By taking everything which is not x to go to the other side. What is there that's not x? H squared. It has to go to the other side. So x will be now equal to p minus h squared. Don't change. Please don't change. Continue with this method. Don't start to do your own stages and whatever. There we have now number 30, f being equal to this, blah, blah, blah. We take the square root to the other side. It becomes squared. F squared is equal to g minus x. You see that examples look like they're the same, but they do change. So I recommend you to make sure you watch every example. Okay, every example. So now we have f squared being equal to g minus x. I see my x is negative again. I take it to the other side to make it positive. F squared plus x is equal to g. Now I can make it the subject because it's positive by taking everything which is not x to the other side. And what is it? F squared. F squared goes to the other side. I now have x is equal to g minus f squared. Simple as that. Wow, there are many more examples. I see there are more examples below that. Wow. Okay, let's keep going. Number 31, there's no hurry. Let's keep going. We have to put all the skills in our bodies. All right? Okay, because this is not the end. There are more videos to come. Let's see. Square root of t minus x is equal to b. Yet another example. We take the square root sign to the other side. Of course, t minus x is equal to b squared. Okay? Now it's b squared. Then what do? I see my subject. This x is negative. I have to take it to the other side to make it positive before I start doing subject of the formula. It's going to be b squared plus x. Now that it's positive, I can go ahead and make it the subject. How? By taking everything that's not x to the other side. And what is that? B squared. So t minus b squared is now equal to x. Right? You're done. Let's go to number 32. We have the square root of b minus mx being equal to g. We take the square root to the other side. We now have b minus mx being equal to g squared. Why did we take the square root to the other side? Because our subject, x, is in a square root. We have to get rid of it so that we can go ahead and make it the subject. Okay? Now, what is the next thing I see? Well, the term with x. Remember that on number 31, I left my x on the right. Don't try and change it to take it to the left. Leave it on the right. It's good. It's good. It's correct. So now I have again b minus mx being equal to g squared. Well, I see that my term with x is negative. How? I look in front of it, right? The sign ahead of it is its sign. So it goes to the other side to make it positive because you can't do subject when your term is negative. So it's going to be b is equal to g squared plus mx. Now I can go ahead and make x the subject, okay? If you can do it, you could be pausing and trying on your own and then confirm it. Now what do I do to make x the subject? I take everything which is not x to the other side, starting with who? M O G, g squared first, because he is further from x than m. So g squared goes to the other side. It will now be b minus g squared is equal to mx. Then who next? M now goes. So it's going to be m was multiplying. He will go to the other side and divide. So it's going to be b minus g squared all over m is equal to x. Great job. Let's do number 33. Number 33 now. I see I have a square root on the left and a square root on the right. Okay, so if you have the same sign both sides like this, you could remove it both sides. Okay, you could remove it, because if I take this to the other side, becomes squared, whatever, just know that if I have the same sign both sides like this, I could remove it on both cases. It would still remain correct. This is the one where they would say, let's square both sides. Okay, it makes more sense to say that. Still the same if we just say, let's remove the sign both sides. Okay, because it's the same thing. Now, what are we going to have? We're going to have qx plus b being equal to a. All right? What else we could have done was to say, we take this square root to the other side. Let me just show you so that it makes more sense, using the method of transposition so that you don't lose trust in it. We could take this square root sign to the other side. What did we have on the right? We had root a. Now, this square root that was on the left comes to the other side, is going to be the power of 2, like that. So we have root a, and root a is now to the power of 2 because we took the square root that was on the left, we took it to the right. Okay? Now, what happens? On the left, we still remain with qx plus b now, but what we're going to have is a fight now between square root and squared. Now, taking square root and raising to the power of 2 are exact opposites. And we saw that when we say things are opposite, it means they cancel out each other. We saw that when I say 7 plus 3, then I say minus 3, I get 7 again. Because plus and minus are opposites. And it's plus 3 and minus 3. Here it's root 2 and power 2. Okay? So root and powers are opposite. And here it was plus and minus are opposite. It was plus 3 and minus 3. So they cancel each other because they are the same values. It's a plus and minus that are opposite and they are of the same value. So root 2 and power 2. These are opposites, and since they are root and power of the same number, they cancel. We will just get a. They cancel out each other. We just get a again. Once it's like this, now we can go ahead and make x the subject by taking b first, because b is further from x than q. Q is right next to x. B has a plus sign between it and x. So we take b first to the other side. We're going to have qx being equal to a minus b. Then q goes to the other side. X will be equal to a minus b all over q. We are done. Number 36. Let's see. Do we have more? Oh my, we have more. Okay, no, we can keep going. Number 34. Number 34, we have p squared is equal to the root of that, whatever. Now we take this. We want to make x. We want to make x the subject. So we take this root to the other side. We will have p squared, and this is now raised to another power of 2 because this square root sign has come to the other side, and it is now just equal to x minus q. So here, this is a bit of laws of indices where you have a power raised to another power. Basically, I'll just give you a quick rundown. In laws of indices, we have 3 laws. The first one says if I have a number with a power a by m, that is multiplying to the same number, okay, whether to a power that's maybe different or the same, we don't care. If we have the base being the same, the base is a. Let's say I have 2 to the power of 3 times 2 to the power of 3 again, okay. I don't care. It could be also 2 to the power of 3 times 2 to the power of 4. I don't really care about the powers, okay? What I care about is the base. This number at the bottom. Is it the same? Yes, it's 2 and 2, okay? It can be 2 to the power of 3 times 3 to the power of 5. No, those 2 and 3 are different numbers. But if you say 2 to the power of 3 times 2 to the power of something, then you can apply the laws of indices. A and A, they're the same. What do you do when the bases are multiplying? When the bases multiply, the powers add. So it's going to be a to the power of m plus n. Okay, so that means this would be just 2 to the power of 3 plus 3, which is 6. And here it'll be 2 again. First you put the 2. It's now to the power of 3 plus 4, which is 7. That's the first law. Second law says if you have them dividing, numbers with the same base raised to powers, if they are dividing, you subtract the power. So it will be a to the m minus n. So if I have 2 to the 7 divided by 2 to the 5, what do I get? 2 to the what? 7 minus 5, which is 2 squared. Okay? And you're done. That's how you do it. Then the last law, this is law number 1. and the one at the bottom is law number 2. Sorry, it's a bit clustered. Then we go to law number 3. It just says if you have a number with a power and that number is raised to another power, what you just do is you multiply the powers. It'll be m times n or mn. All right. So that's the one we have here. P to the power of 2 raised to another power of 2. So we're going to just multiply those two powers. It'll be 2 times 2, and you're going to get 4. So it'll be now P to the power of 4. Let's go ahead and write that, and we can continue with our work. So we could remove this. We don't need it anymore. Okay, we can continue with our work now. It's going to be P to the power of 2 times 2. They multiply because it's a power raised to another power, so they multiply. It's going to be 4, which is equal to x minus q. You just take q to the other side. It's P to the power of 4 plus q is equal to x. Don't forget to do the opposite. Don't take it and make it stay negative. X squared is equal to 7. Now I have a power of 2 that I want to take to the other side. It will be x is equal to the root of 2, and that is the root of 7. 2 root of 7. So but now what I want you to know is every time you do root, you always put a plus or a minus. You put not a plus or a minus, but you always put plus or minus. Okay, it's called plus or minus. Plus over minus, like plus or minus. Okay, to mean that this square root gives me two answers: plus and then negative of that. So the positive one and the negative version. Okay, so that'll be your answer here. You leave it as exact as possible. Okay. For those that want to get something, comma, whatever, it doesn't matter. You could have plus, maybe it's 2 point whatever, or yeah, 2 point something, and then or minus 2 point whatever. Now we have x squared plus n being equal to h. The first thing I do before I get the root is I take n to the other side. I now have x squared, okay? I now have x squared being equal to h minus n. First I take n to the other side. Now I can take the root of it. I can take the power to the other side, it becomes root. X will be equal to the square root of, if there are more than 2, if there's 2 or more things, you put them in brackets like this. Square root of h minus n. We are done. We're done. But remember to put plus or minus outside, because square root yields you 2 solutions. Are we together? Yeah. So now we've reached the end. These are the probably, no, it's not. Oh my, man, mate, this is crazy. Let's keep going. What is the next one saying? Q is equal to P plus X squared. So now I'm making X squared again the subject. I see it's positive, so I'm going to keep it on the right because it's positive. But I'm going to have to do square root to take this power off. But to take it, I first start with everything else. That's the last thing I'm going to take, the power. So P goes to the other side. He will subtract Q minus P is equal to X squared. Then now I take the power to the other side. It's going to be root of Q minus P. If it's root 2, you say plus or minus because it's plus or minus of the root 2, and we just get x. X is now alone. You're done. We go to number 38. M minus x squared is equal to c. Now my x squared is negative. I can't make it the subject when it's negative. It has to go to the other side to become positive first. So m will be equal to c plus x squared. Now that it's positive, I can make x the subject. How? By taking c to the other side first. So m minus c is equal to x squared. Then I take the power of 2 to the other side is going to be the root of 2. Of what? Of m minus c. And what do I put? Plus or minus. And this is just equal to your x. Number 39, let's see. Oh, the fact that there is no number 42 shows that we've reached the end. So now 39 is d is equal to g minus x squared. I take this to the other side first to make it positive because it's negative. So I say d plus x squared is equal to g. Now that it's positive, I can make x the subject. How? I first take d to the other side. So it's going to be x squared is equal to g minus d because d is coming to subtract. Then I take the power of 2 to the other side. It's going to be x is equal to the root of 2, but I put plus or minus outside. Then I put g minus d in brackets under my square root sign. Last two examples, 40 and 41. Lx is equal to p. What do I do now? I first take the L, of course, to the other side. So x squared will be equal to p over L. Now I take the power of 2 to the other side. X will be equal to the square root of p over L, right? The whole fraction. Everything that was there. Square root is going to be of everything that was there. And you put your plus or minus, don't forget. Number 41, h is equal to bx squared. I take b to the other side first, of course. And b is multiplying On the right goes to the left, it will divide. That's the opposite. And that is equal to x squared. Then now to get x, I take power of 2 to the other side. It becomes the square root of h over b is equal to x. I should put plus or minus. Wow, I've reached the end. This is the end of this. See you in the next video. Bye for now.